Hello, I'm Bo from Sweden. Welcome to my channel about the WICS project. Today I'm presenting important updates for the new control panel system. We won't waste any time, so let's start. The manufacturer of the MCP23017 chip changed or updated the specification after finding a problem with the first pin on the both banks. The problem is that the chip is working in a non-latching mode, and if an input signal on those pins was changed in the same microsecond that the I2C bus was read, the signal could be read as illegal and reboot the microcontroller. The solution is that those two pins can only be used for output. All the control panel child PCBs have now been updated to version 1.1 that handles this flaw. There is alternatives to the MCP23017, but they're only available as SMD or breakout module. I don't need 16 input per chip, so I will keep the 23017. Happy days! Simon Coward have released nowRail 2.2.2 that support 8 MCP23017. That means that 4 child PCBs can be connected and supported directly from nowRail. There is 5 new settings that would need to be set for the control panel, and there is 4 new functions that can be used with the control panel. I won't develop any WICS code for the control panel. I will use nowRail functions instead. But I will develop the 2 new functions for the gateway presented in a previous video, W10. Here is the new Child-C PCB. It's almost identical to the Child-B. The only difference is that the 8 push buttons is replaced with 8 toggle switches. By using toggle switches, it's easier to see the current state when there is no LED indicators. I will use these switches to manually control blocks as free or occupied for the sections on my layout that doesn't have any block detector. The mounting height for all the PCBs is 11 mm between the top of the PCB and the bottom of the front panel. The LEDs need to have long legs, typical 28 mm, and the push buttons and the toggle switches must also handle 11 mm of distance. I will present more details about mounting when the enclosure is constructed. Here is an update to the Child-A PCB. Beside the MCP23017 fix, I only changed from blue LEDs to orange LEDs for the 8 LEDs in the bottom. The reason for the change is that the blue LEDs is around 3.2 volt and 20 milliamp. Feeding it with 3.3 volt and a tiny resistor is making the illumination weaker than the other LEDs. Now all the LEDs used around 2 volt and 10 milliamp. Connecting to 3.3 volt with a 220 ohm, the LEDs is only consuming 5.9 to 6.4 milliamp. You could even put a 330 ohm resistor, and then the LEDs will only consuming 3.9 to 4.2 milliamp. Here's the control panel PCB family. The parent PCB with the ESP32 microcontroller, 5 volt power input, and an OLED screen. The Child-A PCB with 8 turnout controls, 8 orange LED indicators, for example sensors. The Child-C PCB with 4 turnouts controls, 4 push buttons with 4 yellow LED and 8 push buttons. And the new Child-C PCB with 4 turnouts, 4 push buttons with 4 yellow LED and 8 latching switches. nowRail support 4 Child PCBs, but you could have 8 Child PCBs if you write your own code for the second I2C channel. Since the control panel will be exposed and the fitting must be exact, I highly recommend that you spend some extra dollar to get industry quality components. The pin socket must be elevated so it matches the standard pin header. Some tech produce that. The LED must have long legs, 28mm, and King Bright has around 2V 10mA for all the color used. The 6x6mm push buttons need a long stick. Same Sky has a 17mm high stick on their push buttons. eSwitch have a toggle switch with a long neck. And Panasonic has a 8mm high capacitors. A low socket 5 to 6mm should be used for the ESP32. All the components is available from both Mouser and DigiKey. You will find a complete component list in the KitKat schematic.
Thank you for watching this video. Hope you enjoyed it. We look forward to sharing our next video with you. Until next time, take care and happy railroading.